Namaste, my dear children, and welcome back. Exams are just around the corner, I know. But don't you worry, let's master this chapter together, and we'll do it in a fun and super simple way. We all use a torch, Hina, especially when the power suddenly goes out. But have you ever just stopped and wondered what magic is happening inside that makes it glow? Come on, let's solve this little mystery. To start any journey, we need energy. And for our torch, that energy comes from a tiny powerhouse. Okay, let's dive into this. The electric cell. Just think of the cell as a small tiffin box, But instead of food, it's packed with electrical energy for our circuit. And it has two ends, or what we call terminals, a positive one and a negative one. See here? Look at that little metal cap on the top. That's our positive terminal. And the flat metal disc at the bottom? Yep, that's the negative one. So simple to remember, isn't it? Now, what if we need more power, like for a big, powerful torch? Well, we just connect two or more cells to make a battery. But there's a very important rule, Beta. You have to connect the positive of one cell to the negative of the next one. Always, always remember that. Okay, so we have our power source, our little tiffin box full of energy. Now, let's look at the part that actually gives us that beautiful light. Let's uncover the secret of the bulb. So if you look inside the glass part of the bulb, you'll see a very, very thin, special wire. This little wire, this is where all the magic really happens. This glowing wire has a special name. It's called the filament. When electricity passes through it, it gets super, super hot and it shines so brightly. And that's what gives us light. Right, so we have the cell for power and the bulb for light. Now, how do we connect them? Well, we need to build a complete path, kind of like a road, for the electricity to travel. Let's see how we build this electric road. And there we have it. Look at that. We've connected the bulb to the cell using wires, and we've created a complete path. This amazing path is what we call an electric circuit. So the most crucial thing to remember is that the path must be complete. It has to be unbroken. Think of it like a racetrack. The electricity starts at the positive side, goes through the bulb, and then all the way back to the negative side. No breaks in the track.
Okay, pay close attention, my children. This is a very, very common question in your exams, so listen carefully.
Think about it. Think about that complete path, that road we just talked about. What could possibly be the problem with a fused bulb? Exactly. You got it. If the filament breaks, our electric road is broken. There's a gap. So the current just stops. It has nowhere to go. And if there's no current, the bulb just cannot glow. See? Remember this simple logic. Now think about it. We don't want our torch to be on all the time, right? That would be such a waste of the cell's energy. So we need something to control the flow of electricity. And that something is a switch. A switch is just like a drawbridge on our electrical road. When it's on, the bridge is down, the circuit is closed, and the current flows happily along. But when you turn it off, the bridge goes up, creating a gap, and the current has to stop. So we've been using metal wires to make our circuits. But have you ever wondered why we use metal? Why not, say, a piece of string or a rubber band? Let's find out which materials are friends with electricity and which are not. Look here, we've put a normal metal spoon in our circuit and look at that. The bulb is glowing. So this tells us that metal is a good friend of electricity. It lets it pass through. So materials that allow current to pass through them are called conductors, and materials that block the current, that stop it, are called insulators. And guess what? Both of them are very, very important. Now this, my dear children, this is the most important takeaway for your safety. The wires we use have metal on the inside, that's the conductor, but they're covered with plastic on the outside, that's the insulator. That plastic protects us from getting a nasty electric shock. So please, always be careful, and never, ever touch switches with wet hands, okay? And that's it. See, I told you it was simple. You have now learned everything you need to know to get full marks on this topic. I am so, so proud of all of you. To finish off, here's a little homework for your curious minds. Just look around your room right now. What can you find that is a conductor? And what is an insulator? Let that curiosity grow. We'll meet again in the next explainer. Bye-bye.